Okay. My talk will be about the database layer of Yi framework 2.0, which I've written a great part of it, and I will tell you about the different layers. First, introduce why we even need a database layer. We can just write SQL code, but there are reasons to not write plain SQL. The second thing will be the introduction of the abstraction layers we introduced in the Yi framework, because there are different use cases and different layers on the database that you can use to work with the database. And it's also possible to switch between layers when you have different use cases, because between the layers we have 3 layers: database access objects, query builder, and active record. And the more abstraction is put on the database, the slower it gets, but the better the code gets readable. So there is always a trade-off between this, and so we have options to switch between these layers. So the first thing, why do we need database abstraction? First thing is that code gets simpler and more readable. So compared to plain SQL, we do not concatenate strings, but we write methods to do something. So things will get simpler, and we hide the complexity behind this database layer. Abstraction allows to structure code differently. So if we create one SQL in one place, we cannot move logic to different places like we have been introduced before. So we cannot easily put things into different places that we can reuse later. So this allows us to reuse code and also to work with MVC better if we do not write plain SQL. So there's also security enhancements. If we directly call methods with PHP arrays, we do not have to care about escaping for SQL injection all the time, but this part is already automated by the framework. So there's the first layer. We have 3 layers. The first is database access objects. Then we have a query builder and an active record, and all these layers are tied together. So you do not have to select one and stay with it. They are all using each other. So the base thing is database connection and database command, where we can simply put SQL strings and execute them. Built on top of that, we have a query builder that is using PHP methods to create queries, and this is using the underlying layer of the database command. And then we have active record, which is to work on a higher level. So we are working with objects instead of working with tables and their relations. We are working on an object level, so we can easier express the relations or the work we do with the object itself instead of working with tables. This is an example for the basic layer. So simple thing, we create a connection. The abstraction layer allows us to use multiple databases. So the basic layer is using PHP PDO to connect to the database. That means we can connect to different databases, for example, MySQL, Postgres, or SQLite independent. So we can use the same code on different databases if it's needed, for example, for CMS software or something that runs on different systems. So this is just the connection uses PDO, and we can use create command. If we open the database in this way and create a command, we can just execute it and query one result or query all results. So this is pretty straightforward on the basic layer. The command already provides some enhancements about creating SQL. So we do not write for insert, update, and delete. We can just use these methods that already escape the code for SQL injection. So we pass, for insert, we pass a table name. and then the data we want to insert into the table, and Yi will take care of building the correct query for that. And the return of insert is a command object that contains the SQL, and calling execute on it will just send it to the database server, so it will be executed. Update is basically the same. We have a table, then we have the data we want to update, and the condition for to selecting the record. Here we can use just plain strings to write the where condition, but we can also already use other code from the upper layer, which I will explain later. That's also possible to use here. And the same with delete. We have a users table and specify the name for the record we want to delete. There are other things in the abstraction layer. So basically, the most of this is already possible with PDO. Also, transactions are possible with PDO, but Yi adds some nicer things around it. And we also add things like read-write splitting for master and slave setups, connection failover, and also an interesting feature is because we wrap PDO because we can add then things like we have in Yi, the features events, configuration, and dependency injection. So the next level is the query builder. Query builder is to use PHP methods to build an SQL query. It's pretty straightforward. If you have a query, for example, select the name email from users where the ID is 42. We select, we just write it in PHP methods to make this code database independent and also more secure. As you see here in the where condition, we have the ID, and Yi will automatically do the escaping for us, so we can safely pass user input in this case. Behind this array syntax, there is also the possibility to specify a string condition. If you need to write more complex conditions, that's not column equals value. You can use different SQL syntax here and specify the parameters using the syntax. And the query also provides methods to retrieve the result. In this case, we get the user result as an array. If we want to express more complex SQL, we can do that. So Yi is not limited to very simple SQL. We can basically express nearly every SQL query you can create, also with this syntax. So we can nest queries. In the first query, we select the IDs from active categories we have in our database, and then we use this query as a subquery. In the next query, we create a query select from articles and select where the category ID is in the active categories, and then retrieve the result. So this is what you see here is the equivalent SQL query for that. And this also works in not only in where, also in select, in from, join, where, and union. So every possible SQL query nested SQL query can be built with the Yi query builder in that way. Okay. So why do we do this? We have SQL not as strings, but as real code. So we do not need to do string concatenation, but we stay in our programming environment PHP, and we do not have to switch between languages. So it's easier to work with, and also it's a lower risk of SQL injection because you just pass values to methods and do not need to care about escaping them properly because it's done by the framework. And it's also possible to pre-create a query and then modify it later. So you have a method that returns a query and then modify it later in a different place by adding some conditions. And that becomes really handy when we come to active record later. So it's more secure, I already said that. And separation of code, yeah, that's what the next flag. So the next level is working with objects related to, that represents tables. So we have a user object that represents records from our users table. And we simply specify the table name so the record knows where to fetch the data from. And then we are able to work with these objects instead of writing SQL. So we have the Yii database active record class. And if we want to create a query to query some users or to query some data, we call the find method to get an active query. And this query extends from the DB query we've seen before. So we have exactly the same interface and exactly the same methods to use for creating queries that now will, if we retrieve the results, will return objects instead of arrays. So we can work with these objects that maybe contain business logic we've written in them. So this is all classes that are active records extend these the active record class, and also if we call find, we can extend the query to provide specific queries. This is what you have already seen in the first talk. There were examples about this. And another nice thing is that active record not only provides the same interface for the querying as the lower layer, but we also have extended model, so we can directly work with the validation and form input functionality that it's provided by the model. So a new user is created, we assign the attributes by post, call save, on success we are happy, and if not we get the validation errors back. This is what it looks like to find users. So it's exactly the same as we have with the query builder, but now the only difference is that when we return the data, we get objects back, which we can then work with. And for example, in this case, we select one, and there are also shortcut methods for selecting only a single record, so you don't have to write this code, or you can directly fetch the record from the database. What's interesting about databases are relations. So, of course, also active record has relations, and we write methods, getters, for getting related queries. So each relational getter will return a method that creates a relational query. And in this case, we specify whether the result will be one record, so it's related to one, or if the result will many records. For example, the profile is one profile per user, and the posts are many posts per user. And these are the queries that are created in the background. If you are working on a high abstraction layer, it's always good to know what's going on in the background. So this is important if you want to understand why your code is slow. You're just calling one method, and in the background there are possibly 100 queries. So you should learn how the queries are executed actually in the lower layers of the database. So in this case, it's very simple. We get one user, and then we get the relational query, where internally Yii knows how the user is related to the profile, because we have the connection where the user ID in the profile class refers to the ID in the user table. And in the syntax here we have this, we always write the attribute that belongs to the related class directly near to it. And on the other side, we have the attribute that belongs to the class that defines the relation. So there's a little difference between relational getters and normal getters, because this method returns a query in this case, but if we call it like this, we directly get the result of the query execution. And we can also use it to customize the relational query, so we call the getter directly without the magic we have with normal getters. So we call the getter, that will return a query as it is defined here, and we can modify it, so we can add, for example, an order by in this case. And the result will then, if you call all, will be again an array of posts. Okay. If we want to work with a lot of users, so we select all users in this case, and we want to iterate over at them, it's important to use this construct which is called with, because if we do not tell Yi to eagerly fetch the related records, the related profiles, in each line of the for each, we will make a database query. If we have a lot of users, that will be really bad. So we have introduced this eagerly loading. We know that we want to work with profile later, and so we specify that Yi should load all the related profiles that are related to the users that we have already fetched from the database. So we get two queries in this case. The first query is selecting the users, and the second is to select the profiles that are related to these users we got. And the relation is automatically populated. So in this line, we do not have any database query. There's a difference between, as you've seen here, there's no join. We do two queries to the database. And if you want to work with the related data in the SQL, so you want to specify a condition that, in this case, is, for example, you want to specify the condition that the status of the profile should be featured, you have to do a join, so the database can access actually this status field to check the condition. And if you do not do anything else, this will imply a with call. So this query will be executed too. If you do not need the relation later, you can specify a false for the join with and skip that step. So there's a difference between joining and eagerly loading the relation. That's what I wanted to point out here. So this is join with introduces this join in the query. And this is just the condition on the query for the where. Yeah, what's interesting on this in the implementation of the Yi active record relational query implementation is that we have no joins. And the nice thing about not having joins for relations is that we can use NoSQL. So we cannot only use active record for a database, but we can also use for SQL database, but we can also use NoSQL databases. So we have implemented this on Elasticsearch, MongoDB, Redis, and Sphinx. So we can have the same interface, active record interface, on all of these systems. So we have Elasticsearch, Redis, MongoDB, and Sphinx. Yeah, we've created active record and active query interfaces for this, and the interface shares common things. They are named like the SQL syntax. For example, we do select, where, order by, or limit, and on the SQL DBMS, these will be just translated to normal SQL queries as you expected. And on other NoSQL databases, these will be translated into the syntax of the NoSQL database. So you can write simple queries like select some user from the table with the condition, and these will work on all these SQL and NoSQL databases if you stay within the interface that is a bit more limited. So you have no joins and things like that, but for simple things this will work. And these are exactly the things we use in the data providers. So we can use data providers to, the same data provider to use, to work with data on SQL database and also on a new SQL database. Because, yeah, select is for which columns we want to have, where is the filtering, order by is, of course, ordering, and limit is pagination. So if we can implement this interface on a NoSQL database, it's possible to have an active record layer that can be used by a data provider and present data in a grid view, for example. And we also, because we also can have relations directly between SQL and NoSQL. So if we specify a relation like user has one profile, and the profile is stored in MongoDB, for example, Yi will just create the query, and the query knows that it's related to a MongoDB instead of SQL, and will load the data from there. Okay, that was active record. Now to switching between layers. Sometimes you just don't want to express some complex SQL in PHP code because it will be much better readable if you just write it in SQL. For complex SQL, it's more often easier to just read the SQL and understand what it is instead of working with the abstraction layer and trying to express what you want in something. Yeah, okay, it doesn't work right. So you want to express the query in plain SQL. So in this case, you can call find by SQL on the active record, and then the result will be returned. Will still return the active record objects. Another thing is if you have a query and you do not need the active record objects, and active record objects often take much more memory than a PHP array. You can just retrieve the result as an array, and so you switch from the upper active record layer to the lower layer. In this case, it's in most cases it's fine to do this, but because we are switching to a lower layer, we have less functionality. With active record, we have conversion of types. For example, if you select things from a database via PDO, everything will be a string. And active record has some functionality implemented that will convert these strings based on the knowledge it has. The active record knows which table it belongs to, so it knows the table schema, and it also knows which columns need to be integer, for example, or which columns are Boolean. And active record will convert these types, so in PHP you will end up with an integer or a Boolean for these columns when you have an active record. But if you do as array, you lose this information, you do not have the connection to the record, and this will result in the result be only strings. So this is something you need to be aware of if you're switching between these layers. There's also YiiDB expression for everything that is not expressible in PHP syntax. We can just use a DB expression and express it in plain SQL. So everywhere the query builder sees an expression, DB expression object, it will just take the string inside and put that into the query that is built. So on a higher level in an active record, if we need some special database syntax that is not available in the Yi implementation, we can still use it by passing an DB expression object and writing the plain SQL code. So in this case, you see the Yi philosophy, which is the maximum flexibility. So we create something that is easy to work with, or to that abstracts things to a high level to write easy plain code. And in this case, yeah, you still have the possibility to switch go away from this abstraction and go down the layer nearer to the database, writing plain SQL if it's needed. Okay, so we have seen the database layers. So we have 3 layers. It's database access objects, query builder, active record, and it's simple to start with. The design is made to be as simple as possible, but also not limited to complex problems. So we, when implementing this, we paid attention to make it as easy as possible, but also as extensible as possible. Yeah, it's possible to use this on SQL, also on NoSQL, and I think that's it. Any questions?